Thank you very much for attending this talk. So it's called Web Application Architecture in Haskell, when the domain drives the types and the types drive the domain. It's a talk intended for a mixed audience of Haskell engineers and practitioners of domain-driven design. And this talk is intended to reunify the two communities of people who know Haskell but have a certain experience of software methodology, and people who practice domain-driven design but know no Haskell. And the centerpiece of this talk is a community website called flora.pm, which is an alternative to a hackage for viewing Haskell packages of our ecosystems. So all the techniques that I'm going to show here are actually implemented in the Flora code base, which you can freely watch, see on GitHub. So in my day job, I am a backend engineer at Scrive. We are a Swedish company. Our sector is the legal sector. We do contract signatures and digital identity interfacing, with the national providers like Bank ID or It's Me for the Belgians here. I used to be a director at the Haskell Foundation. Now I'm just a helping hand, but I remain quite involved in the institutions. I'm also a member of the Haskell.org committee. If you find the website ugly, please do tell me. So Haskell, pure functional programming, is quite nice, isn't it? It brings us a bunch of stuff that we all like: Lambda, types, recursion, all those things that now every other programming language has, except when they don't. Quick syntax primer for the newcomers here. This is a record. This is a function. They have fields. They have input types, output types. You can see an argument and the body of a function. We can put constraints on inputs, and if you know other languages, it might look like this, because in Haskell we value terseness. We want to write short code, not so short as to be called Perl mongers, but yet we like short code. We can also have observable effects, which is quite nice, but also quite wide. It's the solution for tackling the awkward squad of exceptions, timeouts, concurrency, reaction to independent input sources, that kind of stuff. So records have a type, which I've called record here, and a constructor to build data. It also has a kind. Kinds are the types of types. Which is, suddenly quite advanced. So we will see later what this can bring us. But for the moment, let's focus on the basic features of Haskell. It can help us represent business domains quite accurately and have a semantic tracking of effects. And we are going to see why it's so good. So, representation of the business domain. It means that if I have a user with a privilege, for example, an access control implementation, I can put a type in the signature of this type. This type data, it's a new extension of the latest GHE version, means that this sum type we will be able to use it at the type level. So I don't have only a user with potentially a field of the record called permission or privileges. I have a user that is always, parameterized by either being an admin or a visitor. And if I want to show the back office of my platform, of my product, I can only accept users that are admin. And it's beautiful because you can omit a check on the field of a record. It's a Boolean. You can omit the check in the validation logic. If you omit such a thing at the level of types, GHE, the compiler, will be, showing you errors. That, you're trying to pass a user that is a visitor to a function that wants an admin. I cannot let you do this. And more interestingly, I cannot let you compile this, and you will not send this code to production. That being said, I/O is a bit frustrating. As I showed earlier, I/O means many things. It means concurrency, it means exceptions. It can mean, so in a sense, it's not fantastic. Because these days, I'm not like a mere monkey typing on my typewriter. I am a systems architect. So oftentimes, my systems have multiple components. And I want to be able to determine what are the interactions of my code with the other components of my system. For example, I have a function that gets the name of an entity. I could have written IO and written the text, which is the name, but I also need to be able to determine what are the interactions with the other components. I first want to check in the cache, in the Redis cache, if I've got the entity. Then I switch to making a database call if this cache is miss. And then I perform logging. And logging isn't often as trivial as printing text on a screen. Oftentimes, in production systems, it means shipping the log somewhere. It means HTTP connection, so network latency and traffic. So these are real things that happen outside of our program, and yet inside our larger system. So I need to be able to keep track of those interactions, because when I want to build a mental map of the system that I have, or when I refactor the code, I want to be able to determine, am I still making call to this platform that I have? Yes or no? So when a type system is both strong and expressive, like what we've just seen, we get a lot closer to something that I call fearless refactoring. What is it? So the pros of fearless refactoring is that we basically get vibe checked by the compiler, which is pretty cool. You are in a discussion, in the dialogue with the compiler. The compiler will challenge you for your hidden beliefs when you try to pass an unlawful type to a function. The problem is that now, your worst enemy is yourself. The compiler will actually be a mirror of you, and the conversation, in the conversation, the compiler is actually a mirror, because you speak to yourself, and you just get reflected the consequences of your mistakes, but thankfully only in development. If it doesn't compile, it doesn't get shipped to production. There are also limits to the sentence correct by construction that we often see in Haskell. Oftentimes we see if it compiles, it ships, and it's fantastic. It is guaranteed to be right. No, it is not, because Haskell is not a prover. There are like concrete limits. There are concrete limits to the kind of things that you can put in your types in order to make sure that your business logic is right. So do write test, pretty please. And we have all materials tests, and Haskell has actually been on the forefront of writing tests, because property testing with quick check is something that is very deeply ingrained into Haskell in terms of culture. When we think property testing, we think quick check. When in other languages think property testing, they Google it and they end up on quick check. So there is something very present in our community in terms of testing, and we just need to adopt them because they're already here. So now this is the part where I told to you about domain-driven design, and in the context of functional application architecture. So we're going to start with the smallest element. It's the bounded context. The bounded context contains a workflow, and it has concrete limits. We know how to talk to it. We know what are its inputs, its outputs. The boundaries are well defined. There is no, how can I put this? There can be no mistake about the boundaries of a bounded context. So, for example, in Flora PM, we have 3 bounded contexts. We can have 2 actually, but it's up to you. We have a web component that is in charge of rendering HTML, of taking user inputs from the interface and rendering it. We have the core, which implements the business logic, and we have a jobs worker. And as you can see, the boundaries are well defined because the web component does not directly speak to the database. So if I want to restrain the kind of database actions that the web component can do, I can do it in one place, in the core. So, it acts as an interesting and very practical, bottleneck in terms of, modifying code. A counterexample would be to have a library and a CLI tool, and, they both expose the same feature, but with different code paths. And for example, a flag could be turned on or off. whether or not, by default, whether or not you use the library or the CLI tool. It's very bad practice, but it exists, and we have to fight that. So, data transfer objects, data access objects, business objects, this is terminology that we can see outside of Haskell, and it's actually very useful terminology. So a data transfer object, basically what is it? It's the shape of your data, like very concretely the shape of your data when you send it over the wire. So it can be JSON, it can be CBOR, it can be protocol buffers. Fundamentally, it's a format, it's a schema of data that is optimized to be sent over the wire. The data access object is more or less the same thing, but with the constraints of a database engine. For example, I don't think I can easily write like sums of products in a PostgreSQL table. But my domain object, my domain logic may need these sums of products and products of sums. But PostgreSQL doesn't care about that, doesn't really care for that either. So you have to have a translation layer between what your program is able to represent with the rich type system of Haskell and the rich data system of Haskell, and what JSON and Postgres are able to represent themselves. So sometimes they're the same thing, and that's the trick here, because you may be tempted and even able to receive a JSON payload, perform some operations on it, and then store it directly into your database as JSON. But sometimes not. And actually, it's only by pure luck that you are not forced to make a clear distinction between these three stages of your data. And one day, you will have to do it. So I think it's important to know that you can do it. You are not forced to accept every input in your system as being the true representation. You can absolutely diverge to do what suits you the most. So here's a little schema. We have our business object that lives inside our bounded context, a data bus to which we send our data transfer object, and our PostgreSQL database, or any kind of database really, for which we serialize our access object. It can look like this. Do not actually do this, because you don't need, and that's like the over-eager practitioner of domain-driven design may try to, perform super atomic separation between every component and, almost follow dogmatically this practice. Do not do this. The DTO between the Floor web and the Floor core components is actually useless, because they are not meant to be used, over the network themselves. So you always have to take these kinds of methodology with a grain of salt. I'm not here to preach, the good word. You have to use your judgment, your critical judgment, when listening to such talks. So, for example, reading configuration. Flora takes configuration from the environment, from the shell environment, according to the 12-factor application principles. So on Flora config, we have what describes the objects that we'll later use. I have the configuration for a database pool. And I have an HTTP port that is word 16, because I actually need to make sure that it's never more than a 16-byte integer. But I can't really use a configuration for a pool to perform database request. I need the actual pool. So Flora config expresses what I'm receiving from the outside. Flora env expresses what I'm actually using for my application. And so we can perform a well-typed transformation between the two. So I take the config, I make the pool, the actual pool, I get my assets, and then I just return the environment. A nice thing to do, separating commands and queries, it's extremely important, and I will tell you why. So, fortunately, modern database engines are able to provide us with a read-only replica, which means that you are able to read the data from this replica. You're not able to write in it. You're not able to change the state. And really, it's a hard requirement. If you try to send an update on a read-only replica, it will, the connection will crash. The command will result in an error. So it's as a matter of hygiene, it's important, because you should be able to know what kind of operation is read-only what kind of operation changes the state of your system. There are many ways to do it. At work, we have this little dialect where what we do basically is to put all of our read-only functions in a query module and then import it qualified as query. And then, this gives us a visual indicator in the code base. It's low-tech, it's very low-tech, so I'm not trying to sell you like a toolkit, a database toolkit. You can keep what you're using today. You can just separate, like physically on disk, the functions. But we could go further. For example, so I showed you earlier what kind of effects I could put in my functions. I could actually have two effects, a DB query and a DB command effect, which each have their pool for the database, and then from a cursory glance, I can see in the type signature that this function is actually going to be read-only. And it's not always super evident because, for example, on LinkedIn, if you watch the profile of someone, this will perform a change of state because the person will receive a notification. So it's not a read-only procedure, it's a write-only procedure. But view profile is not necessarily something that conveys the act of changing the state of a system. So yeah, these are my anarchistic tendencies that go out here. Let's keep our distance with the state. So it's interesting to keep our distances with the state because then you can separate where the application runs, where the applications run, and where the state is located. It's okay to put a database on your server. It's okay to put the database elsewhere. Do try to avoid storing your data in the same physical memory as your program, because then you cannot run multiple instances of your program without having a case of split brains, where two programs will have two different versions of the same data. You want to have the database or your storage really centralized to coordinate the state of the system. We can also direct our workflows with type. For example, I have this state machine that has 3 members, and I have this workflow that is parameterized with the state of the state machine. I use state machine. It can be a bit scary. It's nothing of the like. So what we can do is really to enforce the state of the data when it passes through a function. If I try to mess with it, so if I have a new workflow that I send to process workflow and then to send back workflow, it's going to be all right. But if I try to give send back workflow a new workflow, it's going to tell me I cannot match processed and arrival because I was expecting that you would give me a function from arrival to departure, but actually I need a function from processed to departure. So where not to go from here in terms of application architecture? Well, if you've done it, stop it. I'm just joking, but actually for Haskell, it's a real advice. Don't try to do too much type safety for SQL, because either you have some type safety that is trivial to implement, or you found a type level toolkit for SQL that manages to implement the SQL semantics. And like it's the golden goose, don't let it go, but it doesn't really exist today. Do not use SQLite for development and PostgreSQL for production, because otherwise you are going to train your muscle memory to operate SQLite in dev, and when you send to production, you have to get a whole other set of reflexes, of knowledge. So it's better to really keep as close as possible to production when you can. And also they have different subsets of SQL, so not great in the end. Do produce documentation though. It's really nice. And types are nice, but also they're a documentation backbone. They serve to help the documentation. So don't stop to types, write prose. And we can write beautiful prose when we want. And actually, I love to write, to read the prose that you write, because the types sometimes are just super unhelpful. There are some guides and methodologies to write documentation. Writing documentation with a purpose is the best. Do come to talk to me about that later. I'll be happy to talk about it. And in the end, here are my sources. Domain modeling made functional by Scott Blashin. It's the techniques of domain-driven design that I've shown with F#. Living documentation by Cyril Martrer. It's perfect. It's not Haskell focused or any FP focused, but documentation lives as with the program. and of course the data taxis documentation framework by Daniele Procida, which is excellent, just purely excellent. Reduce amounts of caffeine, actually don't do that. My doctor is not very happy, and neither is my heart. So thank you very much for listening to this talk.